What's up, guys? So how did the finding the general term thing go? If it didn't, if you're not too sure still how that works, please let me know and I will potentially help you out in any way I can figure out. So like I said, today we're going to be starting to work on the arithmetic sequence. And then we're probably going to do geometric sequence the day after or something. So for now, the one thing that you should know that's not written on this because we're going to skip ahead a little bit is that the general term for an arithmetic sequence is going to be the first term plus what's called the common difference times n minus 1. So this is how we're going to generate the terms for the arithmetic sequence. And we're going to use this thing all the time. So there's other properties actually for the arithmetic sequence that we're able to use. I've looked into a little bit of how they do in the States, and I don't think that they usually see these properties. So hopefully this is kind of new for you. So this first property is what is called the arithmetic mean. And it should be pretty self-explanatory. It's a mean, meaning that it's an average. So any term, so think of an as being, for example, a5 or a6, like a fixed term inside a sequence, is going to be equal to the average between the term that comes before, which is what an minus 1 is, and the term that comes after, which is what an plus 1 is. So these two guys here. So an example just to show you how it works. So for example, if I pick 7, so 7 is the third term. And then if I pick the two terms that come before and the other one after, that would be a2 and a4. That would be equal to 4 plus 10. And I'm going to divide that by 2 because this is what the property says, right? So this is going to equal to 14 divided by 2, which is 7. So as you can see, you can get any term by taking the average of the term that comes before and after. So this is pretty important, I would say. It's a pretty useful property, if anything. Yeah, so that's pretty much it for that. I mean, I can prove it for you. Let's do it because proofs are fun. So how are we going to prove this? Let's see. We can write an plus 1. I hope that in the past you have seen that the arithmetic sequence can be written recursively. Recursively means that it can depend on the term that comes before. So if you look at this, at the sequence that we have, for example, 2, which is 1, 4, 7, and 10, you can get to 4 by doing 1 plus 3, and then you can get to 7 by doing 4 plus 3. You can get to 10 by doing 7 plus 3. So essentially any term, so an plus 1 is equal to the term that comes before, so an plus the difference. So an plus 1 in this case, it's equal to an plus the common difference. That's the point here. Okay, so once we have that, the other one that we have is you could say, well, an is also equal to an minus 1 plus the common difference. Note that this n minus 1 and that this n plus 1, they're in the index. Like I'm not actually subtracting 1 here. What I mean is if I had a4, it would be equal to a3 plus the common difference. So here what I could do is just isolate an minus 1 in this here. And I could say, well, an minus 1 is equal to an minus d. Okay, and I know that you're like, what the hell, where the hell are we going with this? What I'm going to do is I'm going to take my property, which is that an plus 1 plus an minus 1 over 2. We're going to go and figure out what this is equal to using the two things I just put arrows against. So an plus 1 is an plus d. And then an minus 1 is an minus d, right? Minus d. And this thing divided by 2. So what happens is your d's cancel out. And then you get 2an over 2, which is just an. So this is literally it. This is the property. This is the proof that this works and doesn't come out of nowhere. I hope you believe me. If you don't believe me, I don't know what to tell you. So let us move down a little bit if my computer allows me, of course. We're going to go to the second property. So by the way, you should be taking notes of these properties somewhere, because you're going to need them for reference. So this next property is a little bit more complicated. Not that much more complicated, but a little bit. So it's called a symmetric property. So what it says is, first thing that you should notice is here. So we need two pairs of numbers that are equal. So for example, this could be 1 plus 3, and this could be 2 plus 2. So each would be equal to 2. not 4. Yeah, 1 plus 3 is 4 and 2 plus 2 is 4. So you just want pairs of numbers that are equal. And in that case, AL, so A1 plus A3 would be equal to A2 plus A2, for instance. So why is it called a symmetric property? I'm just going to give you this example. So here, for example, if I take A3 plus A4, so that's going to be 9 plus 13, which is 22. Then I could, for example, take A2 plus A5. So notice I didn't pick A2 plus A5 randomly. I took them because I know that 3 and 4 equal to 7 and that 2 and 5 are also equal to 7. And so if I do that, then I get 5 plus 17, which is, guess what, 22. So it's called a symmetric property because if I go on that, like the next term for this one, what are we differencing by? 4, it seems, so it would be 21. So 9 and 13 are equal, 5 and 17 are equal, and then 5 and then 1 plus 21 are equal. They all equal to 22, right? So you can do that anywhere in the sequence. As long as your index are equal, then you know that the sum of the two terms are going to be equal. I hope you can see that. Proof, I mean, it depends how much I have recording time left. I have 6 minutes done. Not too bad. Okay, I think I'm going to skip the proof and I'll come back if I have time because it turns out YouTube cuts me at 15 minutes and that's pretty inconvenient. Don't want to start making too many of these videos, but the proof is very, very, very similar to the one that I did before. So I just want to give you the arithmetic sum because this one is actually pretty essential. I don't know if you've ever seen this notation before. It's not very common that students have. So first of all, you shouldn't be too impressed by it. So the important part here is, I don't know if you guys know, but this letter, this Greek letter, the one that looks like a big E, is called sigma. Sigma. And it's super, super common in math. We use sigma all the time. It means sum. Sum as in addition. So how we would read this here, it would say the sum from the first, which is why the 1 is here, to the nth term of the sequence. This should be an A1, by the way. A1 plus D times K minus 1. So what it means here is we're going to sum the first n term of the arithmetic sequence that is given afterwards. So for example, we have one just below here. So this says we're going to start at 1 and end at 4 for the sequence 2 plus 4 times K minus 1. So how this works is essentially this K here is going to change value. And this is why we have the K right here. It's saying K is going to equal to 1. And then after that, you're going to add this to when K equals to 2, which you're going to add to when K equals to 3, and which you're going to add again to K equals to 4, because that's where it ends. So your first thing essentially would be when K equals to 1, I'm just going to write it up there so you can see. So this is going to be 2 plus 4 times 0, right? Because if K equals to 1, then 1 minus 1 is 0. So this is the first thing you're adding. Then we're going to add this to when K is equal to 2. When K equals to 2, then you're going to have 2 plus 4, because it's going to be a 4 times 1. And then after that, we're going to have a 2 plus 8. And finally, a 2 plus, what do we have? 4 times 4? 3, and then 4. So 4 times 3, which is going to be 12. I don't know if we can see that properly. So what is this going to equal to? So we get 2 plus 6 plus 10 plus 14. Which is what? 8 plus 10 is 18. 18 plus 14 is going to be 32. So that's our sum here. I hope that makes sense. I don't think I'm going to make any other example. Maybe you should try to do this one here in your notebook just to see. Actually, no, don't do that. That until 25. No, let's not do that. I think we're just going to skip ahead because there's something I want to show you regarding the sum. If you can see, it is a pretty tedious mission to do this. Because if you're just going to keep adding numbers like that, like what the hell, no one has time for that. So obviously there's a way that we can make this a little bit more simple. So what I'm going to do is I think I'm going to skip ahead to this S6 here, and I'll show you what I want to show you. So if we want to calculate S6, there's two things we could do. I need a pen. Okay, so we're summing the first 6 terms for this, which are going to be 2 plus 5 plus, we're adding 3 every time, so plus 8 plus 11 plus 14 plus, I need one more, I think, 17. 6, 7. Okay, perfect. So what you could do is we could just say, okay, let's just add them one at a time and then get our sum, right? So visually, like the way I would do it to make it a little bit easier is 2 plus 5 is 7, and then we're going to add this to 8. So what do we get? 7, 14, 15. 15 plus 11 is 20. I swear to God, I don't know how to calculate. 26 plus 14 is 40 plus 17 is 57. Okay. I hope that this is correct. But yeah. So like I said, pretty tedious. The other thing you could do, which makes a little bit more sense, you'll see later why, is you could sandwich that and say we're going to take 2 plus 17, which is 19. And then after that, we're going to take the other 2 ones in a sandwich like that. So we're going to have 5 plus 14, which is, surprise, surprise, 19. Do you remember why it would make sense that these are all equal? I hope you do. This is a symmetric property, right? We talked about the sandwich before. So essentially, your sum is going to be 3 times 19. Do you see that? Which I hope is 57. And of course, I don't know how to calculate it. 57. Wonderful. So what I want to show you here is what we did essentially is we took this 19 and multiplied it by 3. So how do we get 19 and how do we get 3? Well, the 19 comes from taking the first term and summing it with the last term, which in this case was A6, but we can generalize it by saying it's AN. And then we took this number here and multiplied it by 3 because we're essentially taking the number of terms we have and dividing it by 2. This, my friend, is our babe. It's the one we want. It's going to allow us to calculate the sum of any number and just by using 3 different numbers. That's it. So if we want to calculate S100, like doing this example down here, if I can. And let's check how we're doing on time. 12 minutes. Okay, just 1 minute and we'll do that. And then after that, I'm going to give you the formula, which you can already see actually, but. Okay, so S100 would be equal to using the formula to A1 plus AN. So A1 is just going to be 3. We can see it here. This is A1, so it's going to be 3. As you can see, this is a 3, hopefully. And then AN, so A100, let's calculate A100 just so we have it. So we know that the first term is 3 and then 2 times 99. 201 times the number of terms over 2, which is going to be 50. So the sum of the first 100 terms of this sequence is going to be 204 times 50. So 10,200. Just like that. So here, you should take that in note. This is super important. It's the sum formula. So this here is no new. It's just talking about what the sum is. And then the formula that I just talked about is this one. This is another form of it. And it's another form that you can do by just expanding this one here, but by subbing AN by the general term, which is, remember, AN is equal to A1 plus D times N minus 1. So if you just substitute that in the formula, you get this first version of it, which is pretty convenient as well. All right, let me know if you have any questions regarding this.